So still sticking with the parabola, another thing that they like to ask in parabolas is that they give you a parabola and they give you a tangent to the parabola. Okay, so let's say this is a tangent to the parabola and they say give the equation of the tangent. So we know that the tangent is a straight line, which is y is equal to mx plus c. So step number 1, you must first get m, which is the gradient. And then step number 2, you must get c. Okay, so first get the gradient. So how do you get the gradient? So make sure that, let's say for example this point here is, okay, so let's say for example the parabola is y is equal to 2x squared plus 1, and they say the tangent touches the parabola where x equal to 2. So first get the gradient of the tangent. Now remember, the gradient of the tangent is always equal to the first derivative, okay, of the parabola. So to get the gradient of the tangent, you get the first derivative of the parabola. So let's say that's f of x. So you get the first derivative and you substitute the x value of the point of contact. Now this point I call it a point of contact. A point of contact. So so the first derivative of this parabola is 4x. Okay, so it's 4x. How do you get the first derivative? I'm sure you did it in class already by saying 2, the exponent multiplied by the coefficient is 4, and you put that 4 down, you keep the variable and you say the exponent minus 1, and 2 minus 1 is 1, and you just constant numbers, there's no first derivative, you ignore in the first derivative. So your first derivative is 4x. But now, and the first derivative is actually your gradient of the tangent. So you just substitute that x value of the point of contact into that x to get the gradient. So the first derivative, where x is 2, it's 4 times 2, and that's 8. Therefore, the gradient is equal to 8. So remember, the first derivative is always equal to the gradient of your tangent. So the gradient of this tangent is 8. So we got the first derivative, substitute that x value into your first derivative, and we got 8. So therefore the gradient of our tangent is 8. So therefore m is equal to 8. Now we can say y is equal to 8x plus c. Now to get c, there's x and y. So we need a coordinate that's lying on the graph. Then we get to substitute into our equation to get c. So we got 2. How do we get y? Well, how do we get the y value of this particular coordinate? Remember, if you got an x value and looking for a y value, and you got the equation of the graph, you can just substitute that x value into your equation to get the corresponding y value. So all that we can do is that we say y is equal to 2 into 2 squared plus 1. Therefore y is equal to 2 times 4 plus 1, and y is equal to 8 plus 1, and y is equal to 9. Therefore this value is 9. So that point of contact, we have to substitute the point of contact, POC, point of contact. We have to substitute the point of contact into this equation to solve for c, because that's the only point lying on the tangent graph at that point. You understand? So therefore, the point of contact is 2 and 9. So 9 is equal to 8 times 2 plus c. 9 is equal to 16 plus c. 9 minus 16 is equal to c. Therefore, c is equal to minus 7. And the equation of the tangent is y is equal to 8x minus 7. So step number 1 is that you first get your gradient. Your gradient is equal to the first derivative. You get the first derivative and you substitute the x value of the point of contact into the first derivative to get the answer 8, which is the gradient. Y is to 8x plus c. Then to get c, you substitute any point that lies on the tangent, and that was the point lying on the tangent, the point of contact, which we got as 2 and 9. They only gave us x, but to get the y, you substitute x into the equation of the parabola, because that point also lies on the parabola. So if you have the x, you can calculate the y by substituting the x value into the equation of the parabola to get the y value. And we got the y value of 9. So if x is 2, y is 9 on my parabola. But this point also lies on the tangent. So we can substitute that point into this equation to solve for the c value of minus 7, and there we got the equation of our tangent y is equal to 8x minus 7. And that's it, everybody, for this question.